All right, in this section, we're going to talk about measures of the center of the data. So one number is often used to describe an entire sample or population. And these measures are often called the measure of center. So we have three measures of center we're going to talk about. The mode is the value that occurs most frequently. The median, we've already talked about when we did measures of location, and that's the middle of the data value. And then we have the mean, which is also the average. So we already know how to calculate an average. We add up all the data values and divide by how many we have. This is called the mean in statistics. So here's where we have a little bit of notation for you coming in. We have the lowercase n represents sample size, capital N represents population size, and this Greek epsilon or Greek symbol here means to sum or to add. Now, sometimes they'll have underneath like I equals 1 to n here. It's just telling you what numbers to sum. Okay, now here's some important notation you need to know. The sample mean is, we say this x bar. So x bar is the sample mean. So if we have a set of sample data, this formula is telling us to add all the values together and divide by the sample size. The population mean notation is mu. So if we were in the classroom, I'd say, okay, everybody say mu. So say mu. This means, again, we add all the data values together, and this capital N is we divide by the population size. So the key here is, in a problem, you'll have to know the difference. Is it a sample? Is it a population? The calculations are the same here, just a little bit difference in the notation. Okay? All right, so let's just look at an example and calculate these. The Stop and Go convenience chain recently selected a random sample of 10 customers. The store monitored the number of times each customer made a purchase at the store over a 2-month period. The following data were collected. Compute the mean, median, mode. Okay, so let's look at our calculator here and go ahead and put these into our calculator. Move my calculator over here for you. All right, so remember we're going to go to my favorite button here, Stat, and we're going to hit Enter for Edit. Now I want to clear this list out that I put in the other day. So what I'm going to do is arrow up to the top so my cursor is over L1, and I'm going to hit Clear and Enter. Now if you arrowed up and you accidentally hit Delete here, it will delete all L1. So we do just have to reset your settings to get that back. So just make sure you hit clear right here and then enter. There's different ways to clear the list, but this is just one way. So let's go ahead and put our data in. Let's do 10, enter, 19, enter, 17, enter, 19, enter, 12, enter, 7, enter, 22, enter, 15, enter, 16, enter, 13, enter. Okay, now the calculator will give us both the mean and the median directly, but the mode we will have to see for ourselves. So the mode is the data that occurs most frequently. Now you may be able to look at this and tell right away we have two 19s. But let's go ahead and sort our data in the calculator so we can double click that. So go ahead and do second quit. We're going to do stat. Go to number 2, sort A. We're going to tell it list 1, so we do second number 1. Hit enter, your calculator will say done. Go back to stat, edit, and it sorted my list from smallest to largest, so I can see the only number that occurs twice is the number 19, making my mode 19. Okay? Now the median, because there are 10 data values, And you can see that by arrowing down here. When the cursor's over number 22, you can see here it says 10. So we want to go, the middle is going to be, let's see, I'm going to count 1, 2, 3, 4, 5. So it's going to be in between 15 and 16, right? Because there'll be 5 numbers here and 5 numbers here. So in between there is going to be 15.5, in between the number 15 and 16, halfway between. Now the calculator will do this as well, but I'll show you this in a sec. I just wanted to show you if you sorted it, you can easily see that. Remember, if we have an even number of data values, we have to average the two middle numbers. Had we had an odd number, 11 data values, then the middle number is the median. Okay? Now for the mean, remember our formula here because this is a sample. They've selected a random sample, so we're going to use X bar. My formula is the sum of X over N, little n because it's a sample size. Okay? So what I want to do is add all these numbers together for my numerator and divide by 10. Okay? So I'm going to do second quit here. And I'm going to go to, there's a couple different ways we can do this in our calculator, but the first way is I'm going to do second list. It's right above the stat key. And I'm going to arrow over to math. Okay, and I can see here, basically this will tell me different things about my list. If I want to find the minimum value in a list, the maximum, the mean, which is what we're trying to find here, we can find it directly, the median, the sum, the product, the standard deviation, the variance. So I'm going to go down to sum, just so that I can show it in my formula here. I'm going to tell my calculator L1. So I end up with a sum of 150. So that means I'm going to take 150 divided by 10, which will give me 15 for my mean. Now let's go ahead and double check that by doing second list over to math. Let's find the mean. We'll do second L1. Whoops. Sorry about that. Second L1. Okay, second quit. Second L1. Enter. And you can see my mean is 15. Let's go ahead and do the median as well. Second list, over to math, down to median, enter. Second L1, enter. What did you get? 15.5, yay. Okay, so that's one way. Anytime you have your data in a list here, you can always do second quit first before you calculate it, otherwise it'll put it in the list. But you can do second list, over to math, and there's all these functions you can do. All right? Now another way we can do this is go back to our favorite button, Stat, over to Calc, and we used this button when we did the 5-number summary, the 1-var stats. Let's hit Enter. My data's in L1, so I'm just going to hit Calculate. And again, it's going to give us all the sum. Remember this arrow here? We could arrow down and see that 5-number summary at the end. Well, of course, the median's right there, 15.5. My arrow back up. You can see here it gives me the X bar right away, and it also tells me the sum of X. So if you need to find the formula, you can have that right there. Now the sum of X squared is used in a shortcut formula for variance, and we'll talk about that in a second. And then S and sigma are the standard deviations we'll talk about in the next section. And then it gives you the sample size and then your 5-number summary. Okay? All right. Now this last question says, which measures of central tendency will be affected by extreme data values? So what you want to think about on your list here, when we talk about extreme data values, if I look at my list here, let's say my 22 instead was 220. That's an extreme data value, very far away from the rest of the data. Well, does that change my median? Remember, the median's the middle here. It does not, right? Does that change the mode? Nope, my mode is still 19. But does it change the mean? Yeah, because when I add all those up, now I got a lot bigger number. So it's going to increase that mean here. Okay, so the mean is most affected by extreme data values. Okay, now we can also calculate the mean of grouped data. So if we have group data in a frequency table like this, we actually don't know the actual values. We have to estimate the mean by calculating the mean of the frequency table. And this is the formula for that. And I think I forgot a divide sign right there. It's the sum of the frequency times the median of the class, or the middle, divided by the sum of the frequencies, which will end up being our sample size. Okay, so what if we have this? This is a statistics class with some tests. This is not my class, okay, because I don't have people this low, right? You're all going to get A's. So there was one student got between 50 and 56, none who got in this range, 4 in this range, 4 in this range, 2 in this range, 3, 4, 1, okay? So in order to find the average here, we're going to find the midpoints for all the intervals, and then we're going to calculate the sum of the product of each interval, and then divide that by the sum of the frequencies. Now, our calculator will help us out in this, but we do have to find the midpoints of these. So let's go ahead and do that. On my calculator, I'm going to hit second quit here. And I'm going to do 50 plus 56.5 and divide it in half. That will give me the midpoint of that first class, 53.25. All right, so I'm going to calculate all the midpoints here. Now, once we get the second one and we know the class width, we can just add that down. So let's do 56.5 plus 62.5 divided by 2 is 59.5. Okay, go ahead and complete that. Okay, so you should have all the midpoints in now. Once you've done that, just hit pause and you can double check that. Okay, so now what we want to do is we want to calculate the sum of the products. So I'm going to go ahead and put these midpoints into my calculator. So again, I'm going to go up to the top of this list, hit clear and enter. And I'm going to type these in, 53.25. Oops. Okay, so I went ahead and entered the midpoints in L1 and the frequencies in L2. So a couple different things we can do here. We can multiply them and sum them. We can do this whole thing. So let's go ahead and go to second list, over to math. This is where you can do some of the products. You can do the sum of L2. But let's go ahead and actually just calculate the 1-var stats on this. And I'll show you how it will give it all to you. So our list, our medians are in L1. Our frequency list then, we only use this when we have group data. We'll put in L2. And then we'll hit calculate. And so it's going to give us our mean of 76.86. It also gives us the sum of the frequency times the midpoints. So this is the numerator of this formula just right here. And then your n is the sum of the frequencies. So in our formula, what we have is the mean of this group data is equal to the sum of the frequency times m over the sum of the frequency. So this equals 1460.25 divided by 19. And if we divide that out, we'll get the actual mean here, 76.85. Make sense? Okay. Okay, so once we have the measures of central tendency, there's something we can notice about them when we talk about the skewness and shapes of our distributions. If it is symmetrical, then our mean will equal our median, will equal our mode. If it is left skewed, our mean is less than our median is less than our mode. And if it's right skewed, our mean will be greater than our median, which will be greater than our mode. So looking at these two examples, in this one, the histogram is for this data, and it's not symmetrical. You can see the right-hand side's kind of chopped, and it's kind of drawn out to the left here. So it is skewed to the left because it's being pulled to the left. So when that happens, it's pulling the mean in that direction. So in this distribution, our mean is 6.3, our median is 6.5, and the mode is 7. And the mode tends to always be the highest bar. So basically in a left skewed draw, it's pulling the mean and median to the left. That's why the mean is the less, then the median, then the mode. However, in right skewed data, again, our mode is going to be the tallest bar, and then it's pulling it to the right. So the mean is going to be the largest, and the median's in the middle of those two, and then the mode. Okay, the last section in chapter 2 is going to do measures of variation or spread of our data. Now, don't be overwhelmed by these formulas here, okay, because the calculator does a lot of this for us, okay, but just be able to, you do need to recognize the symbols. S squared is for variance, sample variance, and sigma squared is for population variance. When we take the square root of those two, we have the sample standard deviation and the population standard deviation. Another formula we're going to use is the coefficient of variation, and this is where we take the standard deviation and divide it by the mean and multiply by 100. Basically, this allows us to compare measurements from different populations in case they have different units. We're just carrying percents. And then there's two formulas, or two rules, Chebyshev's theorem and the empirical rule, that we'll look at.